In this part of the video, we're gonna mesh doctor our 3D model in Blender and then bring it back to Meshroom for some texturing. So fire up Blender, go File, Import, choose OBJ, navigate to the folder with the model, and hit Import. So that is our mesh, but before doing anything with it, I'm gonna right-click in the bottom of the user interface and enable Scene Statistics. So we can see that it's approximately 1 million vertices and 2 million faces. And wow, it seems that the Z-axis was flipped. We thought that we sorted out the orientation, but not as fast. It isn't recommended to change the mesh orientation itself because it has to be re-exported back to Meshroom, so I created the empty object instead. I'm gonna parent our mesh to this empty object. Select both objects, with the empty being the last one. Right-click, Parent, Object. Now, on rotating the empty objects, the mesh will follow all the changes in transform. And in addition to that, our empty will record the changes that we do, so we can roll it back just before exporting it out. So then it all aligns perfectly with the Meshroom coordinates. Okay, next I will add the cylinder that will serve as the Boolean cutout object. Let's crank up the vertices count to make the cutout a little bit smoother. We can click the X-ray icon to see through things, and S and X to scale the cylinder horizontally on the X-axis. And then I'm going to select the photoscan asset, come over to the modifiers tab and choose the Boolean modifier. Right away I will switch it over to the fast mode, because well, it's fast and we are dealing with considerable number of polygons, and the mode should be switched to intersect instead of difference. Then I'm going to pick the cylinder as the operand. And that constrains the asset to the shape of the cylinder. Now we just have to apply the modifier, and lastly we can select the Boolean object, press X and get rid of it. And toggle off the X-ray mode. Alright, so technically what we did is just imported this photoscan into Blender, modified it. We could have edited the mesh itself or applied any kind of modifier or adjusted it via sculpting, for example. It doesn't matter much at this stage. What we did is made some change to the mesh, but because we have the empty object around, we can revert the transform of the object and get it back to reality capture for some texture projection, for example. Alright, so far so good. Should we show some sculpting techniques though that may come in handy? What do you think? Alright, I think we can take this risk and stretch this section a bit more to show how the mesh can be cleaned up via sculpting, just in principle, you know. By the way, now I will save this blend file to load it up once we mess it with sculpting. Just keep in mind that this sculpting section is not supposed to be followed along, or you can obviously do it if you wish, but be sure to save the file so we can get back to it. Often, if the photoscan is good enough, cleaning it up means denoising it. The high-frequency perturbations in the geometry is the scourge of photoscans, and the Blender sculpting mode comes to the rescue. In the left tool shelf we can find all the brushes, and if the mesh is dense enough we don't need dynamic topology, and I think 1.7 million polygons is already dense enough. And now, what brushes could be useful for denoising the geometry? The flatten brush comes to mind instantly. It's my favorite brush for this kind of task. It works in kind of a simple way. It really does flatten the geometry. It can't be put better than that. The strength can be controlled at the top of the user interface, and that's especially useful if you do it with mouse. If you use tablet, the strength can be controlled via the touch intensity. And needless to say, that makes the whole process much more intuitive and just generally faster. And then you just gently massage the mesh along its curves, and the flatten brush is intelligent enough to not wipe out all the detalization in those places. That is my #1 brush when it comes to manual mesh denoising. It's really good. Then we have the smooth brush that can alternatively be invoked with the help of the Shift hotkey with any kind of brush. It is even more nuclear than the flatten brush, so you have to control the strength if you don't want to transform everything into marshmallow. But in small doses, that's also a nice medicine for the noise. The third brush, which you can place roughly in this denoising section, is the scrape brush. Actually, the settings for all the brushes can be found in this menu. Say, if you want to adjust the radius, the fall-off, the strength, the direction, the texture, whatever else, it can be done from this menu. You can explore it if you wish. So even though the scrape brush works kind of similar to the flatten brush in terms of polishing the surface, it has the very strong hard surface connotations. Imagine having to clean the photoscan of some mechanically engineered surface, something along these lines. It's a fairly unique brush, and it fulfills this unique role. It's very easy to overdo it though, so I would be careful with using it. Again, maybe in cleaning up the mechanical surfaces it has its place, but it's a little bit, freestyle. So the flatten brush is super useful for reducing the noise, the smooth brush, then probably the scrape brush from time to time. If the photoscanned mesh has some really cursed spot that has to be filled with concrete, then the clay brush may come in handy. It literally builds up the virtual material in crevices so we can fill the entire caverns of chaos with this clay. And sometimes it's the last resort. It's the last thing that we can do to clean up the photoscanned mesh. Now loading up our backup as promised. What I recommend to do with such meshes is just give it a slight treatment of the flatten brush. By the way, the tool shelf with the brushes can be toggled with the help of the T shortcut. So what I'll do here is apply a small and fairly insignificant layer of flattening with the flatten brush, obviously. I will fast track this to not bore you to death. At this point, I want to encourage you to try the sculpting brushes, the flattened brush specifically, to see what you can squeeze out of this mesh in terms of quality. And once you played with the baking tools, we can export this cleaned up and sculpted mesh back to Meshroom for some texture reprojection. Alright, so let's imagine that we have done everything that we wanted to do with this mesh. We trimmed it. We sculpted it out ever so slightly. What we need to do now is open the right tool shelf with the Transform tab and reset the rotation of the empty. As we remember, all the changes in orientation have been recorded in there, so let's input 0 in the X rotation field and that will bring it back to its original value. If we did everything right, after exporting this mesh out back to Meshroom, it should align perfectly with the previous parameters. So I'm using the OBJ export once more, creating a separate folder for it called HighPoly Tweaked. Limit the OBJ export to selection only. The other properties should be left at their default values within the Geometry tab. And I think we should be good to go, maybe after renaming it. HighPoly Tweaked. After successfully exporting it out, we can press Ctrl Z a few times to undo a few steps and bring back the rotated version of the empty. Chances are, we may want to return to this file later on and fix something. After our mesh has been cleaned up in Blender, it's time to return back home into Meshroom and do some more texturing. We don't need the Publish node anymore, so I'm gonna hit Delete. Now we have mesh filtering and texturing nodes to do. Let's push them over to the right like this to free up some space here. Then I'm gonna right click, go Mesh Processing and add the Mesh Decimate node. This node will be our workaround to actually load the OBJ mesh from Blender. Otherwise we'll simply get an error that I'll show in a moment. So I'm removing the connection that was previously going into the mesh input of mesh filtering and reconnecting the output of Mesh Decimate instead. Next we're gonna define the input of our freshly created OBJ file here. So I'm gonna drag it over there. Let's also set the simplification factor to something insignificant like 0.99, just for the purpose of reworking the vertices of the mesh basically. Right click, compute. As I've said, we need to do it like this because for some reason mesh filtering node doesn't accept our mesh. I don't know why really, it could be a bug. Actually, let's try it out. I'm gonna paste the path to the OBJ file into the mesh filtering mesh input and try to calculate it. And boom, the progress bar turned terrifying red. So that's why we needed to pre-process the mesh via the Mesh Decimate node first. So I'm setting the smoothing iteration to 1 in mesh filtering for some extra polish, and now it should be perfectly fine. I think it could be a bug of how Blender exports the OBJ files, or at the same time it could be a bug with how Meshroom interprets them. But anyway, now we know the workaround. Double-clicking on the mesh filtering node opens it up in the right panel. I think it is worth hiding the rest of the meshes to get a clear view on our new one. It's ready for texturing, I think. Before feeding in the second set of inputs specifically designed for texturing, let's try to process this node as is to show something, namely to show how the texture file type set to TIFF will look like, and generally to show how the overly sharpened file with cranked up contrast will look like. Hint, not great, not terrible, but you will definitely see the color management issue related to TIFFs. So double-click on texturing to preview it in the viewport, and if for some reason you don't see textures, it can be switched on in this menu. So as you can see, the diffuse texture turned out to be significantly visually darker than our input photos, in addition to weird contrast and sharpening that we did for better processing of geometry. That is related to how Meshroom does color management. Specifically, it used an EXR format under the hood for pre-processing the sources. And now, after spotting TIFF as a texture file type within texturing node, it basically converted everything to sRGB color space. But what would be the safer workaround to avoid any confusion with color profiles and stuff like that? We're going to sort it out in a moment. For now, let's right-click on the texturing and duplicate this node. Let's sort out two issues at once. First of all, let's connect the inputs designed for texturing into this node, and secondly, let's untangle the color management puzzle. In order to branch texturing like this, we would want to have two copies of prepared and scene node. So what can we do is duplicate this node and have a look at its settings. It should have the images folders drop-down menu where we can hit the plus icon and define the path to the folder with the sources meant for texturing. As a quick reminder, we had two folders, one for geometry, the second one for textures. The one for generating diffuse and later on albedo texture was slightly flat looking and as if deleted already. This one. Let me copy the address as text, Alt-Tab into Meshroom and paste it over here. Next, it would be brilliant if we connected the images folder output of this node all the way to the corresponding input of our second texturing node, if that makes sense. To cut the connection, I'm gonna right-click on it and choose Remove. I hope the user interface is big enough in order to see it. Anyway, now we need to connect the images folder input and output like this. It's important to not mess the connections somehow, and it is hellishly easy to do that actually. We need to be extremely careful with nodes. As for the settings, let's keep the texture side at 4K resolution. We can go slightly higher if we wish to, but I think 4K will be quite enough. The downscale at 1, meaning original resolution, and the texture file type to EXR instead of TIFF. Lastly, the unwrap method should be set to LSCM, otherwise Meshroom will generate a whole bunch of textures, like 10 textures instead of 1, and I think we would like to see the texture nicely packed into one file. It took approximately 10 minutes to generate the texture, which is not that bad. Let's double-click it to load up the preview in the viewport. Let's hide the stuff that is blocking the view, and here it is! An amazing high poly mesh with UV map and diffuse texture ready to go. It took us approximately 47 minutes to fully calculate this photo scan with texture in Meshroom, and actually I'm really satisfied with the quality. Maybe not so much with the processing time though. I wonder, what do you guys think? In my opinion, it's pretty good and usable as an asset, especially considering that's the free and open source pipeline. That is by itself mind-blowing, I think. As a finishing touch, let's take the model plus texture out of Meshroom via the publish node. The mesh and the texture as well should go into the input files. As usual, the output folder has to be defined. Let me create a separate one called High Poly Textured. And just drag it into that window. Right click, go compute, and there it should be dumped into that folder that we have just defined. And indeed it is there. Perfect! So that is it for the first major part of the tutorial, where we managed to generate a pretty good photoscan mesh using 100% free open source and cross-platform pipeline. In the second part though, we'll take this model and make it game ready by baking textures onto the low poly version of this model,